Well, hey everyone, and welcome to another video. On this one, we're going to continue on the implementation of some methods on the linked list class that we started last video, and then we're gonna end up on this one. And I think we finished last video implementing the toString function and then testing out some values and making sure that everything was working. And now we're going to continue on with the removeFirst function. And well, if you want to remove, I'm going to erase all these. And if you want to remove the first element of the linked list, it's similar to adding really. What we have to do is just think a little bit about the structure of the linked list. So this is the first, and let's say we have a first pointing to this one which has a value 10, and then a next to a 20, and this one goes to null. Well, if you want to remove first thing we have to do, the one thing we have to do is just update this first position or the first pointer to the next one. So if we want to remove this one from the linked list, we essentially just have to update the first update the pointing instead of to this node to the node after it. So we can exit this node just saying that first.next. This node right here won't be accessed to anyone because no one's going to be pointing to it. So what Java does is through the Java garbage collection, it will delete this node from memory, and then essentially what we have is we delete this one, and the linked list will now be only 20. Will be like this, and before it was 10 and 20. So if you want to delete or remove the first node, what we have to do is, well, if we want to remove, we have to return the value. So, in this case, we will and remove first, and just like we talked about, we have to say that the value to be deleted. So we create a node and we'll call this deleted, and this will be our current node. And what we have to do is to update the first pointer to point to the node next to the current node, the current first, right? So we say that first, book the first.next, and right now it will be just like this. Then this one will be erased from memory by Java's garbage collection, and of course we have to decrease the size and then return the deleted node. Okay. Well, this is the removeFirst function. For the removeLast, I think it's best for me to erase all this, and let's say we have a more long linked list. I have this node which points to this one, points to this one, which points to null. So it'll be a 1, a 2, a 3. And this is first, and we have the size. In this case, it will be equal to 3. So if you want to delete the last node, what we have to do is to go to traverse the list and go to the node before the last node, in this case this one. So what we have to do is we have to update the next attribute on this node, the one before the last node. We want to update so that this one will point to the next of the next value that it has already. So in this case, we have to update this one. We have to erase this. Have to erase this connection here, and now you update the next so that it points to the next of the next position. So in this case, we're gonna jump the node we want to be deleted, and then we will return this one. So all I have to do is to use the same method we used before. We create a current pointer, which will starts pointing at the first, and then we loop through until we get to the node before the last one, and then we do this method. We update the next variable of this one to 2 nodes ahead. Of course, we have to be careful about extreme cases. So for instance, if this linked list only had 1 node, if this only have, if we're like this, what would happen? In this case, we don't have the next attribute, because if you try to, this one is the last one, and if you try to go to the previous one, we didn't have any. But we'll see how we'll deal with this soon enough. We'll create this function which will return a value t. And now we want to create a node cur, it will be equal to first, while, now here's the thing that we want to take care. At first we have to say if first is equal to null. What's gonna happen? Of course, we have to change this one here because we didn't talk about extreme cases here or odd cases. But let's deal with it already. So in this one, if we want to remove first, if the list is empty, we cannot access the first.next because the first will be null, and then we will have a null pointer exception error. And what we have to do here is just take care of this and say if first is equal to null, then we just return null. If the list is empty, we just return null because we didn't delete anything. And else, we do this. We say that the deleted will be the first one, and we say that the first will be now first.next, decrease the size, and return deleted. And on this one, we have to do something else. Because it will be one case when first will equal to null, right? If this is null, what we have to do, we just return null, the same thing as the other one. Okay. And now we have to check if the size is equal to 1. Because if size is equal to 1, we just want to delete this one, okay? Because the first node is also equal to the last node, and because the linked list only has 1 element on it. So essentially what we want to do if the size is equal to 1 is just remove first, right? So if size is equal to 1, we say that we return remove first, and that's it. Since we are returning it, the remove first function returns the deleted value, and that's the one we want. Well, we already took care of the edge cases, so now we're going to implement the general solution, which is go to the last one, go to the node previous to the next, and then update the next to 2 nodes ahead in the linked list. So while core.next.next is different than null, what do? We say that we traverse the list. Core is equal to core.next. And now, after we get out of this loop, core will be equal to the one after that, not after, before the last node, and we say that node t deleted is equal to what? It's equal to curl.next, which will be this one that's going to be deleted, and we're going to return this. The function is returning this, and then we say curl.next is equal to curl.next.next, and then return deleted. Make sense? So the edge cases were if the linked list is null, and if it's null, we just return null. Not if the linked list is null. If the linked list is empty, and if the linked list is empty, we return null, because there's nothing we can do. We cannot delete anything. And of course, we cannot forget to decrease the size here, because we're deleting things. And if the linked list has a size to equal, if it has size equal 1, then the first node will also be equal to the last node. No, what I want to say is the last node is also the first node, and we can delete this by using the function we just implemented before. And if it's not one of these cases, then it's the general case where we can do this, and we go to the node previous to the last node, say that the next node to this one is 2 nodes ahead on the linked list, decrease the size, and return this value, this node here. And of course, we don't want, again, I'm making a lot of mistakes here, but we don't want to return the node per se. We want to return the value within the node. So we do this by saying deleted.value. Of course, we don't want to return the node itself. I'm just checking if I made any other mistake here. I don't think I did. We'll probably see it when we compile this. Well, the next one is contains, and it would be nice to visualize things again. On this picture here, if I want to check whether there is any value, for instance an 8, what we do is we do the same strategy again. We traverse the list, we go through the list and check for each current node. We check the value, and if the value is equal to the value we want, then we return true, and if you get to null, return false, right? Because if you get to null, we didn't find any value. So this one should be straightforward too. So public, we want to return a boolean, contains, and want to contain a value x, let's call it. And then again, we will create a node with type t. We call it n. That will be equal to our first. And then not n. Cur. That's what we were calling it from the beginning. While cur is equal to null, we check if cur.value is equal to x. Of course, it's really easy to fall into this mistake on Java, but we don't compare things. We don't compare two objects using the equal sign. We use dot equals. So we want to check. Okay, so if x, or if cur.value dot equals x, in this case it will compare the two values, and they are the same type, and if they are equal, I will return true. Then I continue traversing the list. Cur is equal to cur.next. And if I get out of the loop, if I get out of the while loop, that means that I didn't find any value, and I just return false because I didn't find any. Okay, let me see if everything's correct. We first start by assigning a current position to the first current node to this one. Then we loop through to the end, and if I find a node with value x, I return true. Otherwise, I just return false. Yeah. Now let's start implementing the remove method. But before we do that, I think it's best for me to clarify some things when it comes to the method addLast and the method getLast. In the method getLast over here, I forgot to treat an edge case over there, and it's when the list is empty. So I have forgotten to make this comparison here, because if the list is empty, otherwise it's the same thing as if the first element or the first node is equal to null, I have to return null. Otherwise, when I go over here and I test whether the cur.next method is different than null, cur would be null, and cur won't have any method or any attribute next. So I would get a new pointer exception error over there. So this is the line of code that I had to use to not get a new pointer exception. And in the addLast method, I forgot to treat this edge cases where the linked list is also null, and if it's null, it won't have any items on it at all. So I have to, and if the list is empty, I would just have to add first the value, and if not, I just go through all this, because I have to check, otherwise this cur.next here will give me a new pointer exception error just as before. So I have to treat these edge cases over there. So after that, let's start implementing the remove method. First we have to think about what does this remove method do exactly, and what we're trying to do is, so let's get our conceptual image back and see what does the remove function actually do. Let's say we want to remove a current value or a current element in a given position. Let's say I want to remove the second element of the linked list. So if you use indexes like on arrays, this will be the 0th position, or this is the element at the 0th position. This will be in the first one, this will be in the second one, and so forth. And if I want to remove the second one, I have to remove the element at the first position, right? So this will be the 0th position, the first position, and if I want to remove that, I will have to use remove1, and then this will be remove. If I wanted to use, for instance, remove2, I would remove this one, and if I wanted to remove the first one, I would just remove 0. So that's essentially the basics of the remove method. But first, I think it would be best for us to start implementing an easier function, and this method will be the get method, because we would essentially use this get method to get a value in the linked list. So if I want to get the first one, I just use get 0, and then get 1, get 2, and so on and so forth. So I think perhaps it's better for me to start implementing the get method, because it's way easier than the remove method. So let's start implementing. This will be a get in public. I want to return a value t. Get, this will be an integer because it's the position. I'll call this pos for position, and then let's get our board up on the screen. So first of all, let me just draw again. First, let's say we have 2. Let's say we have here a 1 and another one, 7, and let's go to null. If I want to get the first element, or the 0th element in the index, this will be 1 and 2. If I want to get this one, I just start at I create a node, and I point this node to the first node, and then essentially I have to make a for loop, and then I go from 0 to the position that I want, and I just keep increasing, or I keep updating the current node, just as we were doing before with the other methods. So this is cur. Let's say I want the position 1. So I just do a for loop from 0 to 1, and I just keep updating this cur to be the cur.next. So if I wanted the first one, the for loop will only enter on itself once, and then I would update this, and let me erase this. We'll update this cur.next, and we'll point to this node. So the for loop, you would get out of the loop essentially, and then you just return the value within this node. So let's start implementing this. So basically we have to deal again with the edge cases. For instance, if the user input or uses some position which is a negative number, for instance, or the position is greater than the size of the linked list, we want to check that so that nothing happens and nothing is returned from the method. So if we can do this by using the conditional if pos is less than 0 or pos is greater or equal than size. Because in this case, if the position is equal to the size, then it's already out of the linked list, and we just have to return null in both cases. Return null. If it's a valid position, then what we do is we create a node t cur, and we assign that to first. Then we do a for loop from 0 to pos and increase the I variable, and then we keep updating cur is equal to cur.next. And then after that we just have to return cur.value. So the get method, it's already implemented. So let's start thinking about how would we implement the remove method. Let's get our image again, and essentially what we have to do is first we would have to check or to be aware of this edge case here, and we have to check whether this is a valid position. As I told you before, I want the remove method, we want to remove a value, or in this case a node, from a given linked list. So we have to check whether the position is a valid position. And first one, we have to, let's say if I want to remove the first one, that would be easy because we already have the removeFirst method. And let's say if I wanted to remove the last element, then I could just use the removeLast method we already implemented as well. So this at least 3 edge cases are covered, because if let's just start implementing in coding while we talk about this. So this is a public t remove. So the first 3 edge cases is they are if the first is equal to null, in the case that if the list is empty, I don't want to do anything, or if pos, let me just fix this to be consistent. If pos is less than 0 or pos, the position is greater or equal to size. If that happens, then I want to return null. And now for the other position, for the other edge case, if position is equal to 0, then I just return removeFirst, because I just want to remove the first position. And then if position is equal to size -1, then I just return removeLast. Now for the other cases, let me just bring up the board again. For the other cases, let me just erase this, not everything, but just this here. And let's say let me just increase this. let's say I have more nodes here. Let's say I have a 10. Let's say I have a 9, and this go to null. This goes to null. So let's say I want to remove the third element or the third node in this linked list. Well, one strategy is, and since we already talked about this, if I wanted to remove the 0 or the 0th position or the 0th element, I just use the our method removeFirst. If I wanted to remove this one, which is the last element, I just use removeLast, and I have to take care of these when I want to move the nodes in between. So now one strategy would be, let's say I wanted to remove the third element, then the element or the node in the 4th position, or a node which has index 3. So one strategy would be to use again the core node and then point to this, and I create a for loop, and then I keep going forward, keep updating the core to be core.next, update to be this one, and then this one. And when I see that the next one is the position that I want, I stop the loop, and then what I do is I assign this node to a new node, which is the node to be returned, and then I update the next attribute of this node to be this one. In Java, that would be like we already implemented. This one will be core.next. So let's see how that would be, how we would implement this. So first of all, I have to, as always, I have to create a node with type T, core is equal to first, and then now we have to do a for loop. We could also implement a while loop, but a for loop, I think it's more understandable, you know. Int I is equal to 0, then I is less than position -1, and I will explain why the -1 over there. So in this case, let me check. Let me just get back that image. If you wanna go to the second, element, if you wanna go to the node in the second index, how many times we want this for loop to be ran? I wanna just core is equal to core.next, just updating the core node. So if you want to go to the element at the index 3, we want to do this 2 times, right? Because we want to update the core to be core.next once to go from here to here, and then twice to go from here to here. So 2 times. So essentially you have to go from I is equal to 0 to position -1, because if you want the position 3, or the element in the index 3, I want to go into this for loop 2 times. Let's say if I wanted to delete the element at the position 4 or at the index 4, I would have to enter this for loop or update the core variable or the core node 3 times. 1, 2, 3 to get this one, and then I update the next attribute of this node. Okay, so after you do that, this core will be the node previous to the one we want to delete, and then we just create a node T, will be deleted, and that will be core.next. That's the one we want to delete, and then we update the core.next, and that will be equal to core.next. And as always, we have to decrease the size, and then return deleted.value. So that essentially takes care of removing a given element in the position pos. Since we already have every method that we wanted to implement done, I think it's time for us to test all the methods that we just implemented. So let's do that. I'll just open up the terminal, and then I will open the test.java file that we had before. Let me just put it here. So let me just compile the test file. just to see if we didn't commit any mistakes there. Okay, then I'm gonna compile this. And first, I just added some odd numbers from 1 to 11, and I printed the linked list, and here we have it. So we have the linked list with odd numbers from 1 to 11, and then now the method that we implemented, we started at removeFirst, right? So let's test removeFirst, removeLast contains, and then the get and remove method. So let's start with the removeFirst. Here, let me say that l.removeFirst, then I want to print the linked list again. Let's say I want to remove the last, l.removeLast, and I want again to see the result, and then I want to check system.out.print line. I want to check if the linked list contains an 11, and since we deleted the last element, it shouldn't. It should be deleted, so that we would expect a false here. A lot contains 11. So let's see the result that we got. Yeah, so in this case, this is the original linked list. Then we delete the first element, so the 1 is gone. Then we delete the last element, and the 11 is gone. And we check whether the linked list contains an 11, a number 11, and it doesn't. So it gives us false. So these methods, they seem to be working, and now we want to test the get and the remove method. So let's add more values here. I'm just instead of this, let's add a 35 and 77, 19, just to make the linked list bigger with more elements. Let us see what we get. Instead of this, let me add some first, just to continue checking the methods. Add first, and then this add first. Now what we're gonna do is we will do a for loop, and now we will essentially print out all the elements of this linked list using the method get. So this will be l.size, right? Start at 0, the index 0, and we're gonna stop at size -1, and then we can just system.out.print. And what I would do here is just I will print l.getI plus a space here, and then at the end I just system.out.println. So that will give me all the elements of the linked list in the same line, and then we will break the line at the end. Let's see what we get. Okay, so basically we got the result that we were expecting, and it just printed all the elements in the linked list using the get method. So it seems to be working now. And now for the remove method. So let's say, let me just erase this, or at least comment it out. Let's say I want to l.remove at the 0th position, so the first one, l.remove, and let's just see how many elements we have here. So 1, 2, 3, 4, 5, 6, 7, 8. Since I removed the first one, then it will be only 7, and I want to move the element at 6, will be the last element. Then I'll try to continue to printing the list here, and then here, then l.remove, I just remove the element at the index 2, and let's see what we get. So here we have this is the linked list at the start, before we started testing the remove method. And I think, let me just try to, I think it's best for me to use another name for this, and it's best to use removeAt, because it's way more, we can understand that we're trying to remove an element at a given position. So let's just change that a little bit. Let's try. It should be the same thing. It's just the name, which is it agrees more with what we're trying to do with the method. So here we have the initial one, and then we remove the first one, so 111 is gone. Then remove the last one. Let me see, 1 2 3 4 5 6 7. What happened here? Yeah, removed the last one, 19, and 19 is gone here. And then remove the element at the index 2, so 0 1 2, remove the 5, and then the 5 is no longer here. So the methods, all the methods that we implemented are already working, and these are again basic characteristics or functionalities of a linked list. We could try to implement way more methods here. For instance, we could implement a method which reverses the linked list. We could try to add implement a method that sums all the elements in the linked list. So we could do a lot of things, but the basics and the core functionalities of a linked list, I think they are laid out here, and I encourage you to try to do this on your own and try to implement some other methods that you might find interesting. So this is essentially it for this video. On the next video, we're going to use these methods that we implemented on the last two videos to try to implement stacks and queues using this linked list class. And we're going to see that these methods, they make it really easy for us to implement these two important data structures, which are stacks and queues. And I hope you enjoyed these couple of videos, and I hope to see you on the next one.